In this video, I'm going to explain about event loops in JavaScript. So first I'll write its definition and purpose. Event loop in JavaScript. Definition. It is a mechanism in JavaScript which checks the call stack and the tech the tasks queue to it is a mechanism in JavaScript which checks the call stack and uh, the tasks queue could decide which the next task to execute. Purpose. First workflow or working of event loop. So how it is run first. If the call stack is empty, first I need to show it with the diagram, but I will write it first, then I will show the diagram. If the call stack is empty, run the run the micro tasks first, all of them. Second, if the micro tasks are empty, run the macro task one at a time. Repeat. So this is the definition. It is the mechanism in JavaScript which checks first. It checks that the call stack and the task queue are they what is call stack empty and are there any tasks in task queue. Then it decides that which task should it execute next, and that there is a complete complete diagram and explanation to it, which I will explain just now. And this is the workflow of event loops. So I'll open the diagram first. This is its diagram. This is the diagram of event loop JavaScript. Here is the event loop. This complete is JavaScript runtime. What is JavaScript runtime? JavaScript runtime is like it is an engine which helps to run the JavaScript tasks or functions. So JavaScript runtime provide it is an engine for a V8 browser engine is provided by V8 engine in Chrome, and for Firefox it is different. So the browser provides some browser environment which is used here. This is the call stack. These are web APIs. This is the event loop. These are task queue and these are micro task queue. In task queue there are macro tasks. In micro task queue there are micro tasks. So whenever we write any functions, if there is function one, function two, function three, function four, likewise, or if there is any task in JavaScript code, first it goes into this that is call stack. First, it goes into this call stack. What is call stack? Call stack uh, is where all the functions are piled up one on the other, and it runs one at a time because JavaScript is synchronous in is a single threaded. Single threaded means one task at a time. So at a time it will have one task and it will at a time it will execute one task. It may have other piled up also, but at one time it will execute one task. That is the property of call stack. So any task comes here, it will execute and it will finally show the output. Any task comes here, it will execute and it will show the output. Task one, task two, or function one, function two, likewise. It will show the output. But if if there is any code of JavaScript where it is asynchronous in nature. Asynchronous in nature means if some of the functions take time to execute, and below it there are functions which don't take time. In that case, the nature of the code is asynchronous. Because of that, it will send that task here in web APIs. What are web APIs? Web APIs are some properties which allow some of the properties like set timeout or local storage or get location, likewise fetch or promises. They run after some time because timeout, for example, timeout takes time if we have a timer 4 seconds. So after 4 seconds, we need the output. So that that property is is shown by uh, web APIs, but the, that function executes because of browser environment. Give may means it approves that property. It gives you that access that you can run this. And now this say the when the asynchronous function are sent here, then it will separate the task into two part. That is either it is a macro task or it is a micro task. If it is a micro task, it will send it here. If it is a macro task, it will send it here. How to decide whether it is a micro task or a macro task? Macro tasks uh, are lesser in priority, and tasks are higher in priority. Like for example, promises. If there is any promise involved, then it is a micro task and it has high priority. And if there are like set timeout, set interval, set immediate, then they are all micro tasks. So all the the flow of the code is first it will check all the synchronous function. The synchronous function will execute directly in the first code here, sequence wise, whichever is written at the top, it will run first. That is why they are synchronous and it will execute here only. But if there are asynchronous, which involves promises or set timeout, set interval, local storage, get location, such kind of task, then it will get here. And once they are separated into these two, macro task and micro task, then after that, here, because the priority of a micro task is more high priority, so first event loop will check is the call stack empty. If the call stack is empty, when will the call stack be empty? When all the synchronous tasks are already executed. So now it will check if the call stack is empty. If it is empty, then it will see if there are any tasks in micro task queue. Then it will see that yes, there are some tasks in micro task queue. Then it will send this task in here call stack, and that micro task will be executed. Likewise, all the micro tasks will be sent to call stack and they will be executed. When all of the micro tasks queue are executed, because this event loop checks all the time and it sends it here because they have high priority than macro task. Then after that, it will this after that when the micro task queue is empty, it will go for task queue. Then it will check if there are any macro tasks present. Then it will execute one task at a time. If there are like set timeout, set interval, two, three functions like that, then it will send one at a time and execute it. That is the flow of event loop. I here one example is also given here. Examples of web APIs and browser environment. What are all the web APIs that are there in inside? One is fetch, one is set timeout, set interval, or set immediate. Console API, the local storage, session storage, geolocation. When the browser asks, should uh, can do you want to access the location? We get it geolocation position that is also there. Log, file list, performance measure, HTML DOM elements. These are all the web APIs. Here, like in this example, directly code is given. So first, from first line here is a promise. So the this one promise will come here and it will be because it is an web API, it will be sent here. No, in first go, it will execute the synchronous task. This is a promise. So this is also a macro task, and this is also a micro task. So first it will show five, and after that, promise promise will go here in web API, and then it will be in high priority, that is micro task queue. Set timeout will go here first in call stack, then in web API, and because it is a macro task, so it will be in low priority, and again high priority micro task. It will go in first call stack and then web API and then micro task. So first it will show one, five, and then one, and then three, four, two, console.log two, comma at time 10 after 1 second. So this will be the sequence five, one, three, four, two. That is with examples. I will make it a little clear. For event loop, first example, if I write event loop, okay, here I need to comment this. These are all synchronous tasks. That is why one, two, three. There's no sequence mismatch. Coming to the next example. One, three, two. Synchronous, asynchronous. So first it will execute in call stack only. This will also execute in call stack. This will be sent to web API and then macro task. And even though it is after 0 seconds, but it will be executed after these three. So that is a simple example. Coming to example number three. One, three, and two again. Even though it is a micro task, but the first it will execute this one. This will directly go into the call stack and execute because these are synchronous. So first one, then three, and even though it is a micro task, then it will show two. First synchronous task, that is one and four, one and four. Now this is a macro task, macro task, and this is a micro task. So 2, 1, 4 micro task has more high priority, so 3, 2. 1, 4, 3, 2. Correct. Now coming to the last example. Here function is written, nothing is being executed, so it will come to this line. Now function is called. When it is called here, the important point here is that when we write async await, the await, whenever we write await, it acts like a pause button. So here the code does not go to uh, console.log2 directly. So here it is like a pause button. The code does behaves synchronously in this case. For promise, when we use async await, in that case it behaves synchronously. So first it will show 1, then await is written, so it will pause here. Till that time it will run this console.log3. So 1, then 3, and then 2. These are the examples of promises. Now, even though it is a big topic in JavaScript, there are some terms. If anything is left, I will just go through it once. What is the event loop? The event loop is a mechanism in JavaScript that allows a synchronous operation to be executed efficiently, even though JavaScript is single-threaded. This I have already covered. It consistently monitors the call stack and task queues, microtasks, and decides what to execute next. This was also I have written. Purpose of event loop allows JavaScript to handle asynchronous operations. That is correct, because synchronous directly get executed in the call stack. If uh, if if all of the tasks were executed in call stack, then there was no need of event loop. But because some of them go to web API and then macro task, so we need event loop and that whole loops circle without blocking the main thread. Correct. Ensures call stack is never blocked by long running tasks. Ensures call stack is never blocked by long running tasks. Maintains a smooth UI rendering by coordinating microtasks, and rendering. This is the workflow of event loop, which I have already explained. J starts executing code, functions are pushed to call stack, which I told at the beginning. Async operations like set timeout, fetch, or DOM events are sent to web APIs. Only the asynchronous are sent. Synchronous run then and there, provided by the browser or Node.js. When the asynchronous task complete, microtasks like from the dot then promise dot then queue microtask mutation observer go to the microtask queue, and macrotasks like set timeout, set interval go into the macrotask queue. This one also I have already explained. Event loop checks if the call stack is empty, flush all the macrotasks one by one. Then pick one macro task and execute it. Rendering happens after micro task and completed but before the micro task. Rendering means changes in the UI. This cycle repeats infinitely, allowing JS to handle async events while remaining single-threaded. This cycle repeats so the main purpose is to handle asynchronous events while remaining single-threaded. Key points to remember: microtasks always run before macrotasks. Event loop ensures non-blocking execution. Okay. UI updates are coordinated so that rendering doesn't freeze even if JS is processing tasks. So that is all about the event loop. Thank you.